Hello viewers, in this video we will discuss on the topic combination of errors. So we have discussed about errors in the previous lectures. So here we will consider a situation like this. So I am calculating the density. So it is mass by volume. So what happens if error occurs in mass and volume? How will you represent the density with error? Similarly, area of rectangle. So L into B. So what happens when you have error in your length and breadth? So the product of length and breadth is area. How will you express area with error? Similarly, the perimeter of a rectangle. So 2 into L plus B. So you are adding L and B. So how will you represent the perimeter with error? Similarly, when you do the subtraction of length and breadth, how will you represent the output? So for all these mathematical operations like addition, subtraction, division or multiplication, you have a common rule to represent the output with error. So first of all, we will see the representation of the errors for addition and subtraction. Okay. So first we can follow for addition. So error in a sum. So let us take two quantities A and B. Let us take two quantities A and B. So I am adding these two quantities. So A plus B. So the output of A plus B, let us take it as Z. So Z is equal to A plus B. So for example, I am taking the value of A as 60 and the value of B as 40. For example, measuring any length, okay, take it as 60 and 40. So now what will be the summation of this A and B? So 60 plus 40 will be, so the value of Z will be 100. The value of Z is 100. So what happens when when I am measuring the value of A and B, if I am getting error, okay. So these are the true values. So when I am measuring the value of A and B, if I am getting some error, means how will you represent? For example, the value of A with error is represented as 60.5 and 59.5, or for the value of B 39.5 and 40.5. So I am taking the value of error as plus or minus 0.5. Okay, so how will you represent the value of A and B? So A is represented as A plus or minus delta A. Similarly, the B is represented as B plus or minus delta B. So delta A is the error in A, delta B is the error in B. So how will you represent Z? So Z plus or minus delta Z. So delta Z is the error in Z. So what is delta Z now? Delta Z is equal to delta A plus delta B. So delta Z is equal to delta A plus delta B. So the error in the final output or final result will be equal to the addition of the error in the individual quantities. This is the rule framed. Okay. So let us verify what will be the value of the output now. So you know that Z is equal to 100. So we have to represent Z with error. Okay. So A is 60 plus or minus, I am representing this one, plus or minus 0.5. So and B 40 plus or minus 0.5. So what will be the value of this 60 plus 40? Adding the true values, we are getting it as 100. Then plus or minus 0.5 plus 0.5. We have to add the errors 1. So 100 plus or minus 1. So Z plus or minus delta Z is equal to 100 plus or minus 1 is the value of output with error. Okay. Similarly, you can do the same process for a difference. So error in a difference. That is, while subtracting two values. So again, I am taking the same value A and B. So subtraction. So A minus B will be, I am taking it as Z. Okay, so let us take the value of A and B as again 60 and 40, the same procedure, 60, 60.5, same values. So what is 60 minus 40? So here the value of Z will be 20. Okay, so how will you represent A with error now? So A plus or minus delta A, here minus B plus or minus delta B. So with Z also, Z plus or minus delta Z is equal to, this is the same procedure. So here also you know that delta Z is equal to delta A plus delta B, not minus. So this is the rule. For addition or subtraction, the error in the final output will be the sum of the error in the individual quantities, not plus and minus for individual one. For both, this is the common rule. So what will be the value of output with error? So A is 60 plus or minus 0.5, minus of B is 40 plus or minus 0.5. So here the value is 60 minus 40 is 20, plus or minus adding the errors 1. So Z plus or minus delta Z is equal to 20 plus or minus 1. This is the way of representing the output with error when you subtract two quantities. So I have done for both addition and subtraction. So now what is the common rule? The common rule for representing adding two quantities, subtract two quantities with error is, so when two quantities are added or subtracted, the absolute error in the final result is the sum of absolute error in the individual quantities. So when two quantities are added or subtracted, the absolute error in the final output is the sum of the errors in the individual quantities. For both addition or subtraction, this is the common rule. You have to take it. Okay. So this is the way of representing the addition and subtraction with errors. So let us verify. So this one. So we are getting the Z plus or minus delta Z is equal to 100 plus or minus 1. So either it can be either 100, 101 or 99. Okay. So let us do it for individually with plus and separately for minus. So A plus delta A plus of B plus delta B. So here we are getting, so 60 plus 0.5 plus 40 plus 0.5. So this is 100 plus 1. So it is 101 when you take all it as plus. Similarly, you can do it for minus, 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 minus. So this is 100 minus 1, just 99. So the error is, so the value of the output is 100 plus or minus 1. It can be either 101 or 99. Similarly, you can do it for the difference also. So it is 20 plus or minus 1. So it can be either 21 or 19. So this is the way of representing the combination of errors for addition and subtraction. So for the remaining things will be discussed in the next lecture. Okay. Thank you.